Okay, why don't we get started? So feel free to come up now or later if you want to have some happy donuts. I hope that you'll, get to have some. And let's see, I'm curious to hear what people thought of the midterm on Tuesday. Any thoughts, questions, reactions? What's that? The curve is your friend, right. I don't know how the grades, I don't have a good prediction, but did it seem, comments on it? How about you? Thumbs, hard, was it harder? Okay. Any other comments on the midterm beyond that it was harder than the first one? Number one, yeah. I remember exams like that where like 1A and you're sort of like, oh boy, this isn't starting well. But anyway, the curve is your friend. But feel free to come up at the break or after class if you have specific questions about it. Let's see. So this week we're not doing the sort of Thursday, Friday office hours, but section will meet as usual. Either later today, depending on when your section is, or tomorrow. Let's see, after today, we'll be 2/3 of the way through the course. So we've covered a lot of ground already. We're going to cover lots more in the next, in today and the 6 sessions after that. Let's see. Before I get started, let me see if anyone has any questions on anything. Or further comments on the midterm. Or the 2/3 term, I guess it is. But any questions? Yeah, we got a question back here. And then I will start passing around these donuts in a little bit, just so I'm not tempted to eat all of them. Oh, sorry. Good duck. That was great. Yeah. Is it not on? Like services, durable goods, non-durable goods, structures, change in inventories. So it wasn't the consumption, investment, government, exports, imports. It was the other one. That's why I put in parentheses, i.e. not the demand components.
So it wasn't asking for like specific industries? Like I was thinking it was asking for like the 5 major.
No. So if you look at the slides for the macro part, like so just go back to the slides, you'll see 5 components, yeah. Yeah. Okay, other questions on it? Any other questions? He's going to run around. Oh, there is a question somewhere. Oh, Laura's got a question. Oh, Laura's going to fix it, I see. It's not working, okay. It was working when you were putting it together. Okay, so today we're going to talk about economic growth. And this is probably the topic that macroeconomists have studied the most over recent decades. I presented last week some data on how GDP per person varies across countries. So we saw that in the US, GDP per capita was about $60,000. Whereas in China, it was about $10,000, and in India, about $2,000. And we had a bunch of other countries as well, like Brazil and Russia and the UK and Germany. So GDP per capita today varies quite a lot across countries, and that reflects very different growth rates of countries over time. So the rate at which the economy grows is a key determinant of changes in standard of living over time. One of the things, if you ask people that they hope often is that if you ask, let's say, people with kids, one hope that they have is that their children will have things better than they did. And the extent to which that is true depends somewhat on the economic growth rate. So if the economy is not growing, then standards of living are going to be stagnant, and things aren't going to get much better from one generation to the next. If you look In the US, over about a 60-year period, GDP per person more than tripled from 18,000 in 1960 to almost 60,000 in 2019. And that is adjusting for changes in the price level over that time. So those dollar amounts are adjusted to 2012 dollars. I think if it were in 2019 dollars, that would be 65K by 2019. And basically, we've grown at about 2% annually. So I showed you a figure last week that showed that if you look over a long time period, over a 200-year time period, it looks like GDP per person in the US has grown at about 2%. Now, the rate of economic growth has varied quite a lot across countries over this time period. So if you look, for example, South Korea, during this same 60-year period, grew more than 6% annually. China and India have been growing very rapidly in recent years. And I'm going to present some data later on about recent changes in growth rates. But really, economic growth, the sort of economic growth that we see today, is a relatively recent phenomenon. So if you look, it really started to take off in the 1800s with the Industrial Revolution. And one of the things that macroeconomists have found is a very important determinant of economic growth is whether there is a sort of system of strong property rights and a strong legal system. These tend to be a really important determinant of economic growth rates. So if there aren't strong property rights, that reduces the incentive for companies to make investments because they're not sure that they're going to be they'll still have them the next year or a decade later. And if legal systems are weak, it's going to be hard to have lots of transactions that are enforced by the rule of law. So those are big factors. But if you look over a long time period, you can see this is a 2,000-year figure, and this is taken from a book by Chad Jones, who's a professor here at the Stanford Business School. So his office is like right over there. And he's one of the world's leading experts on economic growth. He wrote this interesting study a few years ago looking at economic growth over a long time period. And this is obviously not done perfectly. There was not a census bureau back in the year 600 to calculate these things. So he's basically trying to the extent possible, and this is actually data taken from a book by Madison, and this is looking at per capita GDP in the West, which is defined in this book as Western Europe plus the United States. And so what you see is that the population and per capita GDP were pretty stagnant. You can't really see too well here because they're so low, but it really started to take off. Population started to take off even before the Industrial Revolution, and per capita GDP has taken off more since then. So if we look over and just take a few snapshots, if you look at the year 1 AD, now this number is not perfectly precisely estimated, right? But basically, using the best available information, it seems that in that year, more than 2,000 years ago, GDP per person in the West, this is once again the West still, was about $600 per person. And for the next 1,500 years, that barely budged. So 1,500 years later, that was at about $780. So that would only be about 30% higher than it was in the year 1. So only 30% growth over a 1,500-year time period. So that's not very strong growth. We got a question here. Laura, do you have the microphone cue? I forget. Does someone have it? We're working on it. Okay. So yeah. Okay. Yeah, it's not super reliable. So the further back you go in time, the less reliable the data is going to be. So they're trying to do some kind of, it's obviously like completely different what was available in 1000, but they're doing their best to try to, is it working now?
Yeah.
Okay, great. Thank you.
Yeah.
Okay. Do you now why don't you take it now?
It's like fun to look at a graph like this and say, oh wow, GDP has risen so much, but it's like, I think GDP was only really calculated starting in the year like 1800.
Right, so they're using data from the historical record to try to piece together what living standards were, all those many years ago. And so I encourage you to go to look to Madison for more details on the methodology. But it's not just like, people put a lot of work into trying to make an apples to apples comparison here. Okay, other questions on this data? So, but as you can see, it's a relatively recent phenomenon. So basically, in 1,800 years, GDP about doubled from 600 to about 1,200 per capita. And then over the next less than 200 years, it went up by a factor of more than 20. So what we're seeing today is very different relative to what happened in the past in terms of the advancement of economic progress. Okay? And part of this was driven by a shift from agriculture to industry. So if you look back 150 years ago in the US, about half of the workforce was in agriculture, working on farms. And it was even more. If you go back to 1840, it was like 63%. In Japan, it was 80% 150 years ago. So most people were working on farms at that time. And there weren't today, the share of the US workforce that is in agriculture, I believe, is in between 1% and 2%. So, and this was possible. And how could that be? There are so many more people, so much more food needs to be produced. But basically, over time, technology has advanced and allowed people to do more with fewer people. Okay? And this, Herendorf, Rogerson, and I'm not sure how they assemble this data, but this data I think is pretty reliable. It's not as I don't think this was actually 6,000. Whether this was 600 or 700 or 500 is hard to say, but this data here is, I think, pretty reliable. Okay, I'm going to pause there, see if you guys have any questions. Nope, no questions. Great. Okay, so a big determinant of economic growth is the productivity of workers, and this is basically the amount of output that's produced by a worker for each unit of input. And there are a few factors that influence this. So one very important factor is what economists refer to as human capital. So this is the education, the experience, and the skills of workers. So as people get more education, as they get more experience, as they acquire more skills, they're going to be able to produce more output on average than with less. Similarly, the amount of capital that people have the amount of capital that exists per worker, the level, so capital per worker could be, let's say, someone working in a manufacturing plant for, let's say, General Motors, how many machines do they have available per worker? And the level of technology is sort of meant to capture the production process. So this is, you can think of automation as being a big driver of changes right now in the level of technology. But all of these are important factors, and to the extent that there are economies of scale, this can matter as well. But each of these factors can lead to changes in productivity over time. So I'm now going to pass around the Happy Donuts because I'm looking at these, and and so let's see, where do I start? Why don't I start here? You want to pass? Yeah? Okay, great. And let's try to make, if you're really eager to get some, here, can I pass to you guys too? Okay, you just pass it around. I have napkins, but yeah, anyway. Help yourself with that. Okay, and so each of these factors can lead to changes in labor productivity. So what macroeconomists often try to do is come up with an aggregate production function for the entire economy. And this is inherently imperfect because you're trying to summarize output. If you think about it, in the US, we've got 6 million different firms, and so any equation that you try to use to describe the entire economy is going to be imperfect, and that's a generous description of it. But this will often be modeled. Output in the economy is equal to Y, is a function of the amount of capital, K, the amount of human capital, H, the number of workers, L, and the level of technology, A. All right? And so this is basically, we're going to talk about a specific example of a production function in a few slides that sort of formalizes this relationship between total output and the economy. So you can think of Y as GDP of the economy. And in general, as the amount of capital goes up, GDP will go up. As human capital goes up, GDP will go up. Amount of labor, that will increase it. And as technology is meant to be this one measure of how advanced are the production processes in an economy. And you can see this is taken from two figures taken from OpenStax. You can see the amount of workers, their human capital, amount of physical capital and technology, all sort of combined to produce, combined to lead to the amount of GDP, okay? And in general, the amount, all else equal, we prefer to have productivity going up more rapidly rather than less. And it matters a lot whether the economy productivity of workers is going up 1%, 2%, 3%. How much is that changing over time? And that's partly because of the power of compounding. So if workers are becoming 1% more productive each year, within 30 years, that will only have increased output per worker by 35%. Whereas if instead productivity were growing 2% a year, just a small difference, then output per worker would have gone up by more than 80% over that same time period. And Pat Byery talked about this in his guest lecture, where he talked about, in the case of Amazon, a lot of things that they do only improve things by 1%. But if you can keep doing that over and over and over, the power of compounding can lead that to have a huge effect. Okay, and in general, there is a lot of controversy about what are the best policies to lead to higher productivity. In general, so this is a study from the World Bank, Growth Still is Good for the Poor, that argues that fostering economic growth is really the key to reducing poverty. That rather than having lots of interventions, like, for example, in the US case, we can think of the minimum wage, we can think of welfare programs. Maybe those aren't so pro-growth because of the incentive effects that they have. Okay, so this study argues that income for the bottom 20% or the bottom 40% grows with average income. So if there are things that you can do that increase productivity in the economy, that's going to be your best route to lowering poverty. Okay? Questions on this so far? So one of the things that you'll note about this section of the course, the final let's say 7 sessions in the class, is that it's going to be somewhat more qualitative. So we won't be calculating the area of triangles and rectangles as much in this part of the course as we did in the first 2/3 of the course. But there will still be, but anyway, you'll see as we go through this. It's going to be somewhat more qualitative. Okay, and so productivity growth. So when I was in college, back in the late 80s, early 90s, one of the things that many economists were worried about was a slowdown in productivity. So this is a figure taken from OpenStax. This is chapter 20. You can see in the 1950s and 1960s in the US, productivity grew by about 2.5% per worker per year. But it really slowed down in the 1970s and 80s. And there was a lot of concern about what that was going to mean for the future. And in fact, how many of you have heard of Paul Krugman? Got one. No? No more? Okay, so he writes editorials for the New York Times. Do you want the microphone cube? Or no, you've got, or were you? Okay, great. How are the donuts we still got some left? Okay. I guess in back they would, do you want me to hand it? Yeah, you're good? Okay, great. So Paul Krugman, he's a columnist for the New York Times. He's been writing for the New York Times for about 20 years. He was a professor of economics at MIT, and then at, I believe, Princeton, and now at the City University of New York. He also won the Nobel Prize for his work on international trade. But he wrote a book in the 1990s called The Age of Diminished Expectations that was about basically this slowdown. A lot of it was about this slowdown and how people were, it was very disappointing that productivity was not growing the way that it used to, and that was lowering people's expectations for what they could expect in terms of living standards for themselves and their kids in the future. But since then, productivity has rebounded somewhat. So in the 30 years since that, 20 years since then, from 1990 to about 2014, productivity got almost back up to where it was in 1950. And we're going to talk a lot about how to exactly measure productivity. It's an inherently difficult thing to do because the set of goods and services that are being produced is constantly changing. Okay, so it's not an easy thing to do, but there are a lot of people whose job it is to try to do this accurately. So you can see the productivity rebounded in the recent period, and I'm going to show you some data from a recent Wall Street Journal article that shows that lately we've had productivity down in this lower level. Okay, and that is this article right here. So this is an article from a few months ago in the Wall Street Journal. There's concerns about slow productivity growth in the US, and the title of this article is America's Productivity Problem. So this is data from 2000 all the way up to 2019, and productivity data is released quarterly. So the productivity data can be volatile on a quarterly basis, but the longer-term trend doesn't look good either. From a year earlier, productivity was up just 1.4%. And so in the 15 years prior to 2004, productivity growth averaged 2.5%. So, and when it comes to how fast the economy grows, and this is something that presidential candidates talk a lot about, there are two factors at play: how much people work and how efficient they are at getting their work done. So economic growth depends on growth in the total number of hours people work plus productivity growth. Okay, and productivity is something that people really think a lot about. What are policies that we can put in place? So there are all sorts of policies. You can change the tax code to try to give companies better incentives to invest. You can also change schooling to try to make workers have higher human capital, and so that they're more productive in the future. So productivity is a number that macroeconomists obsess over quite a lot, but it doesn't necessarily translate into higher standards of living. And so this next figure shows, this is taken from a presentation by a colleague of mine, Nick Bloom, and he's an economic professor in our economics department. And he did this presentation on productivity a few years ago at the CEPR Economic Summit. And what he showed was that for many years, from let's say 1950 to 1980, increases in productivity mapped 1-for-1 into increases in median family income. You can see that both numbers are normalized so that their 1980 values are 100. Real median family income, normalize it to 100 in 1980. Productivity, normalize it to 100 in 1980. So you see that in the previous, let's say, 25 years, both had basically doubled, okay? And yet, but then in the next 35 years, you can see that these two things went in, had a very different trajectory. So if you look at if you look at productivity from 1980 up until 2015, that's about, I'd say that's about 85% growth, from 100 to about 185, okay? Yet over that same time period, if you look at the living standards for the median family, so that's the family where half of families have higher income, half of families have lower income, and what you can see is that rather than growing from 100 to 185 as productivity did, it grew from only about 100 to 115, okay? And much of the, I mean, I'm not an expert in political science, but I do think that this growing disconnect between, the average standard of living in the economy and the standard of living for the typical family that explains a lot of the discontent lately, why people are feeling very angry, even though at some level the economy is doing really, really well. The unemployment rate is 3.5%, as we're going to talk about later. Poverty rate has come down somewhat, but in general, standards of living for the typical family, so you can think of the median family as basically the typical family, have not improved much over this long time period. So I'm going to pause there to see if you guys have any questions so far. A lot of this is just, or comments. Okay, everyone's good. Let's see. So the key components of economic growth, as I mentioned a little while ago, are physical capital. So this includes property, plant, and equipment. Both the quantity and the quality of this capital are important. And infrastructure can also play a role. So for example, what are the roads? How good is the electricity grid? Those are things that also matter for worker productivity. And all types of physical capital depreciate over time. And the rate at which, so if I get a new computer today, within 5 years or so, it will have depreciated in value. And similarly, that happens with other, some sorts of capital, like physically just wear and tear, causes them to physically depreciate over time. Okay, and this, I want you to pay attention to this. This depreciation is going to be an important thing that we're going to talk about in a few slides when we get to a specific model of economic growth. Technology includes innovations and improvements. So this can be anything that is anything that is leading to better efficiency. So this can include automation, I think, is the biggest example of this. Manufacturing in the US used to be done more by hand, by individuals, and increasingly, if you go to a manufacturing facility, a lot of it is done with robotics. And so that is, that's an advance in technology. Human capital, what's the knowledge and skills of workers? So I can show you a figure here. If you look over a long time period at what share of US workers, this is for people 25 and up, have a college degree or more, 60 years ago, that was only about 5% had a college degree or more, whereas by 2012, and this is the most recent data that was in OpenStax, that's up to almost 30%. So that quintupled over a 50-plus year period. And similarly, if you look back then in 60 years ago, only about 40% of people in the US over 25 had completed high school, whereas that more than doubled over the next 55 years, okay? So those are, and what we find when you look at what people earn, people who, let's say, have a college degree tend to earn more than people who have only a high school degree or don't have a high school degree, and that reflects their higher level of skill. And so an increase in the amount of capital per worker can be referred to as capital deepening, and studies for the US have tended to find that technology is a key driver of economic growth, as are both types of capital. And if you look across countries, why is it that some countries do so much better than other countries in terms of their economic growth? If you look back 200 years ago, standards of living didn't vary that much across countries, and now they vary massively from 60,000 per person in the U.S. to 2,000 per person in India and many other countries as well. Cross-country studies tend to find that market-oriented economies tend to do better if government policy is pro-growth. Okay, so in general, the more pro-growth are the policies, the higher tend to be the standards of living. But as we've talked about, standards of output may be increasing in the economy, but that doesn't guarantee that, let's say, it's advancing for everyone at the same rate. This is the amount of physical capital per worker. So this goes all the way back to 1950. So almost 70 years ago, or it is 70 years ago, about $10,000 in capital per worker was the value of this capital. This is the value of the physical capital measured by plant and equipment used by the average worker in the US economy. And so you see that almost tripled, or if we had the data through 2020, I'm pretty confident this would have tripled over this long time period. Okay, let me pause there for 1 second. And I think the big question that many people who look across countries at how at standards of living with GDP per capita, one big question is whether there is going to be convergence in the level of output per person across countries. So we see some countries like the US, the UK, Germany, Japan, Australia have much higher GDP per capita than many other countries. Is it going to be the case that there's going to be a catch-up, a convergence? So convergence in GDP per capita around the world. So many less developed countries have grown quite rapidly during recent years. And so to some extent, they are catching up with industrialized countries. And China and India are two of the most prominent recent examples. So in general, GDP per capita is growing more rapidly in China and India than it is in countries like the US and elsewhere. But whether that sort of convergence will continue is very much open to debate. So partly, one reason that you may think that it will continue is there may be diminishing returns to capital. So if we were able to get this same kind of data for India or China, we would find that it was much lower. I don't know if it's exactly here or exactly here, but it would be quite a bit lower today in terms of capital per worker than it is in the US. But you can think of there being diminishing returns to this capital so that if we had, let's say, I referred to this K as the amount of capital per worker, and this was, let's say, the amount of output per worker, and I'll define this in a second, we might think that there's a diminishing return to more and more capital, okay? So if that is true, if there's diminishing returns to capital, then someone who's down here in terms of capital per worker versus a country here, they're going to tend to have higher growth if they increase their capital per worker, more growth than in the country with the higher level of capital. So India and China are starting at a relatively low level, let's say if we look today, relative to the US, and so it may be the case that there will be convergence. But so that would be arguments that we think convergence will continue. But others are less convinced, partly because of the advance of new technology in countries like the US, that is continually shifting the production function of rich countries. So it may be the case that, let me show this. If you have the same level of capital per worker, and we're thinking of, let's say, output per worker, holding other factors fixed, you may have one schedule that looks like this with a certain level of technology, A1. Okay, so A is going to be here, the level of technology. But if over time, richer countries are continually advancing in terms of their technology, this function can go up. So yes, there's a bigger gain here for the poorer country, but if the country that's up here is moving to a higher and higher level of technology, that can offset this diminishing return to capital effect, okay? And lately, convergence has definitely slowed down, but with convergence in GDP per capita, it's likely to be gradual. So if China grew at 5% annual and the US at 2% annual, it would take 68 years for China to catch up to the US. If India were to grow at 5% annual and the US at 2% annual, it would take 122 years, okay? And so this increase in technology is shown here. You can think of capital deepening and new technology. Imagine the economy starts at a point like R with the level of physical and human capital C1 and output per capita at G1. So this is this aggregate production function that I talked about earlier, okay, but looking just at the level of output per worker against just physical and human capital. If the economy relies only on capital deepening while remaining at the technology level shown by the technology 1 line, then it would face diminishing marginal returns as we go from R to U to W. However, now imagine that capital deepening is combined with improvements in technology, Then as capital deepens from C1 to C2, technology improves from 1 to 2, so there's a bigger increase in output per worker coming from having both factors improve at the same time. Okay? Does this make sense? Got a question right here. Let's see. Oh, okay, that's right. Okay.
Can you explain again why there's diminishing return of capital?
Right. Well, for the same reason that there's so essentially, if you think of let's go back to our barber shop example, and if you had, going from 1 to 2 chairs is going to give you a much bigger, this is like a super simplified example, but if you have let's say 3 barbers and only 1 barber chair, going from 1 to 2 is going to have a much bigger return than going from 2 to 3, and certainly than from going from 3 to 4. So just kind of thinking of it in a similar way. So that's at a highly simplified level. But if you think of, let's say, there's going to be the first capital is going to tend to be the most productive, and then the incremental value of new capital is going to tend to decline. So I don't know if that makes sense. That's the example that OpenStax often goes to as this barbershop example in terms of capital per worker. It doesn't have to be true, right? But it has also been shown that empirically, if you're adding, if you let's say you give a farmer, you go from there having just a rake to, let's say, having I don't know, a piece of equipment that they could push, but that would be mechanized. That would probably increase their productivity much more than going to a slightly better version of the mechanized production. So, other questions on this? Okay, great. And it doesn't have to be true, though, but studies have tended to find that. In general, many countries have grown rapidly. If you look from in the 1990s and 2000s, the country that tends to stand out when we look at economic growth is China. So China has grown quite rapidly over time. Vietnam grew very rapidly. And Ireland grew really rapidly over this time period. So you can see here several, this is basically, they refer to this as the fast growth club. And in general, it is true that over this time period from 1990 to 2008, low-income countries and middle-income countries tended to grow more rapidly than the high-income countries. So you can see that if you take basically middle-income countries actually did better than low-income, and that's partly because China is falling into the middle-income group, and they had such rapid growth. But this data suggests that convergence has been going on from 1990 until about 2008, but the more recent data suggests that this convergence has slowed down. And that's especially if China and India are excluded. Okay, I'm going to talk about a recent report that was released just a few weeks ago. Each year, the IMF, the International Monetary Fund, releases something called the World Economic Outlook. And in this publication, they basically are projecting that economic growth globally is going to get better from, let's say next year relative to last year, and that this is driven to a large extent by emerging economies, by growth being higher in emerging economies. If you look at advanced countries like the US, they're predicting growth of less than 2%, and this is in growth in GDP per worker. And so this is, similar. This suggests that convergence will be continuing over these next few years. And they actually go and they have economists who are assigned to each country throughout the world to try to project what is growth going to look like. And so if you look at their projections, you don't have to know all these numbers, but you can see, like in the US, growth in 2018 and 2019 was about 2.9 and 2.3%, and the expectation is that that is going to be slower this year and next year. Similarly, if you look at some countries, they have not been doing well at all. So take Italy, for example. Italy's economic growth has not been great over this time period. China and India still stand out, and they are projected to keep growing more rapidly than other countries. And they are really if you look at convergence, China and India are important drivers of this. Okay, but they changed their outlook for countries from one year to the next. So if you look, the most noteworthy change in this figure, so this is what are the difference from their October 2019 World Economic Outlook projections. So from just a few months earlier, the outlook in India has actually gotten a lot worse in the views of the International Monetary Fund over this time period because of some political changes that have happened in that country. They're less optimistic about growth going forward. So these numbers represent what is the difference in growth in 2020 and 2021 than they had been projecting just a few months earlier. Okay? And you can see other parts so sub-Saharan Africa is projected to grow somewhat faster than developed countries, whereas Latin America has not been doing all that well. And so this basically, in the same way that there's a lot of interest in what's happening to GDP and GDP per worker in the US, there's a lot of interest in understanding how this is changing around the world. Okay, with that, I'm going to go start to talk about the solo growth model, but I'll pause here to see if you guys have any questions on any of this. Okay, making some sense. Okay, great. So the Solow growth model. So Robert Solow is a very famous economist. I can't remember if I mentioned this in my first class, but it was when I took a class with Robert Solow that I decided to switch into economics at MIT. He won the Nobel Prize in 1987 for research that he did on economic growth. And there's something called the Solow growth model that we're going to talk a little bit about over these next few slides. And it basically relates, here this is just a production function for the overall economy, making output in the economy a function of the level of technology, A, the amount of capital, K, and the amount of labor, L. So we're ignoring here human capital, okay, in this equation. You can augment this equation to try to capture the level of human capital. And the coefficients, so K is raised to the power A, L is raised to the power B, and A and B are considered to be less than 1, reflecting the fact that if I double the amount of capital but have the same number of workers, I'm not going to double the total output, okay? And if we assume a constant returns to scale production function, so that means if you double K and L, then that means you double Y output, then you can simplify this to have B equal to 1 minus A. So the production function for the overall economy is equal to the level of technology A times the amount of capital raised to the A power and the amount of labor raised to the 1 minus A power. Okay? And this is obviously a gigantic simplification for what's happening in the economy as a whole. This is trying to simplify the complexity of the economy into one equation. Okay, and it's obviously highly simplified. Okay, if we have constant technology and a population is constant at L, the only things that will influence the amount of output growth is the amount of capital. And we're going to walk through an example of that now, thinking about changes in the amount of capital in the economy. Okay? So there are two things that cause capital per the total amount of capital to change. One is depreciation, the rate at which capital that you, let's say, invest in today depreciates from one period to the next. And I'm going to simplify this and assume that there's a depreciation rate of 25% per year. Okay? In other words, a computer that you buy that's worth $1,000, let's say, in year T, is only worth $750 in year T plus 1. It doesn't have to be years, it can be time periods. And then another thing that's going to influence the amount of capital is the amount of saving. and we're going to assume people save a constant percent of their income, in this case 20%, and assume that all savings are invested in capital. So when people save money, that creates resources that are available for companies to invest in the amount of capital. Okay? And so this is going to tend to reduce the amount of capital from one period to the next, whereas savings is going to tend to increase capital from one period to the next. Okay? Is this making sense so far? Yeah? Okay, you guys are quiet this morning. Okay, great. So let's convert total output to output per worker. So total output Y, we're just going to divide each side of this by the number of workers, L, and that is going to simplify this equation from before to just be the level of technology A times the amount of capital per worker raised to the A power. Okay? And let's assume for right now that A is equal to 0.5. That makes the math a lot easier, so that Y is equal to level of technology times the square root of K. Okay, and we're going to suppose initially that we have a country with a relatively low level of capital of 900. Okay, so that's the total amount of capital per worker, and we'll assume the level of technology is equal to 100. So you would be given these numbers if you were asked to work a problem on this. This implies that the amount of output per worker Y is equal to 100 times little k to the 0.5 power. Okay, and if we think about how this is going to evolve from one period to the next, that 900 in capital per worker, it'll depreciate somewhat. So by 225, so that will tend to lower it by 225. But it is also the case that there are savings happening, and we assumed that people are saving 20% of their income, so we're going to multiply 20% by the total amount of output per worker, which is this Y equals A to the K times K to the 0.5 power. And so savings are equal to 600. So in this example, with the numbers that I've given you for capital per worker and technology, the capital stock is going to tend to grow from one period to the next. So in this case, it's going to grow from 900 to 1275, because 900 minus 225 plus 600 is 1275. And K is going to increase until there's an equilibrium with savings equal to depreciation. And I'm going to show this graphically in a second, and then then we can take a break, but feel free to ask questions on this. Okay, so this, I want to graph here the amount of output per worker as a function of the amount of capital per worker in the economy. Okay, so in terms of depreciation, the depreciation is just a straight line. I'm sorry, this should not be Y. This should be savings and depreciation per worker. Okay, this line is simply equal to 0.25 times the amount of capital per worker. That's equal to the depreciation. The amount of savings is going to be a function, S is equal to 20% of, this is 20% times 100. I'm going to erase this, sorry. 20% of 100 is 20 times K to the 0.5. And that function is going to look like this. Okay, and this point where the two intersect is going to be the point where we are at an equilibrium in terms of the amount of capital per worker. Okay, below that level, let's say if we're down here at like 900, as we were in the example before, we're going to get some depreciation. And I haven't done this. Let me move this a little bit. Okay, I'm going to move this over a little bit. So we had depreciation of about 225 in that example, and we had savings equal to 600. And as this happens, as we go from one period to the next, the amount of capital per worker is going to tend to grow until we get at this point. And at this point, the depreciation, the rate at which the capital is decaying from one period to the next, is exactly offset by the amount of savings of new capital per worker, and so the two perfectly balance. Okay, so I'll pause there for a second. Why don't we take a 10-minute break, and then we'll be back in a little bit. Feel free to come up if you have questions on this so far. Okay, let's get started. So I got some good questions at the break. One issue with this equation that I just want to point out is these exponents A and B. So this is a gigantic simplification of what's happening in the economy, and it's not meant to perfectly capture what's changing. But people ask me, what about A and B? How do we know that they're less than 1? And I think the easiest way to think about that is just like if you double the amount of capital holding fixed the number of workers, output is unlikely to double. Okay, output is going to tend to go up less. And it's ultimately an empirical question whether A, this equation even is a reasonable approximation to the economy, and B, what are the magnitudes of numbers like A and B. It is true that if you take the log of both sides of that equation, it does become additive. So it would be like log A plus A times log of K plus B times log of L. Okay, so it is it's additive in that sense in terms of growth rate kind of sense, but these numbers A and B are to be estimated empirically, and to the extent that this equation does a reasonable job of approximating total output, more often you see estimates for K of 1/3 and for L of 2/3. The reason that I picked 1/2 was just that's the easiest with the math in terms of the example. And then also, there was a question about, there's an interesting recent study by an economist here at Stanford named Marshall Burke looking at climate change and economic growth. And it's interesting because lots of things are changing over time, the level of technology, but there's also big changes in the climate around the world. And that may not make that big of a difference in Palo Alto or New York City, but in many parts of the world where agriculture is still a dominant part of the economy, it can change the productivity of agriculture. So studies have tended to find, and depending on the part of the world, climate change can actually be good for GDP in some places. But my understanding of the literature is that overall it looks like it is slowing global growth as opposed to increasing it, and that it's a potentially important factor. Okay, let me see here. And you're going to be talking more about this solo growth model in your sessions this week. And it's an interesting model that has stood the test of time, and I think is but you can see any of these three things: increases in level of technology, increases in capital per worker, and increases in the number of workers can lead to increases in output, total output. Okay, I'm going to pause there. Did anyone else have any questions on this before I go to? So basically, so this figure right here this was the delta K, which was equal to 375 in that example. And so K, the next period, will be here at 1275. And then you'll see a similar delta K, and that will tend to increase things up to this point, K star. And if K gets above that point, K star, then depreciation is going to be higher than the amount of savings, so it's going to tend to go back towards the left, and there's basically a sort of gravitational pull towards this level of K star. Now, it may be the case, though, that this is an economy we're assuming A is stable. If A is increasing, then that will lead to increases in this thing. Okay, so this K star level could be increasing over time as well. Okay? And so the implications from this model, given the assumptions, were, so just the key parameters that we started with, output per worker is AK to the 0.5, technology was A at 100, depreciation 25%, and savings of 20%. And so if you go through this, in the equilibrium, when we get to an equilibrium point, the total investment is equal to savings. Okay, and that's going to yield K to the 0. So this is S, this is the amount of savings that's happening in the economy, and that's equal to the amount of depreciation per worker in the economy, and that yields this equation that gives you the amount of capital per worker, And then that can just be plugged into this equation up here, once you have the amount of capital per worker, to get the total amount of, this is k to the 0.5 equals 80, so the amount of capital per worker is 6,400, and output per worker in this example is 8,000. And this is the unique value so that savings is equal to depreciation, okay? And that just falls out of the model if you just substitute in. Okay. Questions on this? This is a little different than the sorts of equations that we've seen previously, but the key factors in this are the level of savings, the amount of depreciation, and level of technology A. Okay. So now I want to go pivot to talking about unemployment. So that was just chapter 20 of OpenStax that we just covered. This is now going into material that's covered in 21. And so introduction to unemployment. We've already talked a little bit about the unemployment rate in previous classes. So the unemployment rate is defined to be the number of people who are unemployed in the economy divided by the number of people in the labor force. And this is arguably one of the 2 or 3 most watched measures of economic performance. So right now in the US, it is like incredibly low. So this is like a very, this is not typical. When I TA'd a version of Econ 1 more than 20 years ago, and the unemployment rate was also similarly low then, but there was a sense that I think the idea that unemployment could have gone down to 3.6% was people were very surprised then and are surprised now. And so a person has to have been seeking a job to count as unemployed. And there are really 3 main categories. So every so there are 2 main categories for the labor force. You're either employed, working, or you're unemployed. And the sum of these 2 equals the number of people in the labor force. And this is updated every month by the Bureau of Labor Statistics. So there's this monthly survey of more than 60,000 people that happens every month that asks people about, are they working? If not, why are they not working? Are they just like out of the labor force and not trying to find a job, or are they trying to find a job? And a person could be out of the labor force because they've retired, because they're a discouraged worker unable to find a job, because they're in school and so forth. But this is, this survey is closely watched. Like the first Friday of every month, there's a jobs report that's released, and it provides detailed information about this. So economists are usually at 8:30 Eastern time on Friday, the first Friday of each month. They're on the edge of their seat looking to see what is going to happen with the most recent data. Who has the microphone cube? Is it? Who's got? Oh, great. Thanks. Question right here.
So if I applied for a job and handshake and I didn't get it, but I'm not I wouldn't would I be counted as unemployed because I've been seeking to find a job even though I'm also going to school or whatever?
Right. So I think you would probably be counted as out of the labor force. It would depend on if you were going to school full time. I think you would tend to be counted as out of the labor force. But you may say, oh, and I'm trying to get a 10-hour-a-week job as well. There are people, though, who work, there are plenty of people who are counted as employed in this data who are only working 10 or 20 hours per week. So what's your hunch on this? I think if you're in school full-time and you're looking for a job as an RA, what do you think? I'm pretty sure you would be. I'm not 100% sure. So it gets into this somewhat blurry territory. I think if you're enrolled in school full time and you're just kind of looking for a job, I think my hunch is you'd be counted as unemployed. But I'd have to look at the battery of questions and we'd have to see how you would answer them. Does that help?
Yeah.
Yeah. Great. Okay. Yeah. Throw it back. Great. Okay. So this is a survey of 60,000 people that's done every month. And there's also a survey of establishments from the Bureau of Labor Statistics that estimates by how much the number of jobs has gone up over time. Okay, and so if you look at the January 20 jobs report, which was just released 10 days ago or 2 weeks ago, the unemployment rate is at 3.6%. And there's basically, if you look, they look at the population 16 and up, and there are about 260 million people in the US in that group. And by the way, there are analogous agencies in France, in Japan, and in other countries that are charged with estimating unemployment data for those countries. There are, of the 260 million people who are 16 and up in the US, about 165 million of them are in the labor force. So that's not quite 2/3 labor force participation rate. Of those, a relatively small number are unemployed, only 3.6% of that 164.6 million. Another 158.7 million are employed. Now, one reason, one potential reason, and I haven't seen empirical support for this, for why unemployment has become relatively low in recent years, is that a lot of people in the past who wouldn't have been able to find a job, they may be doing work in the gig economy now. So, for example, maybe driving for Uber or Lyft or working with TaskRabbit or what have you, and the sort of barriers to entering those kinds of jobs may be lower. So this unemployment rate declines with educational attainment. So if you look at people with a college degree or more, only 1 out of every 50 is currently unemployed, whereas it's about 1 out of 18 high school dropouts are unemployed. Okay? And the unemployment rate also is much higher, let's say, among younger age group, among, let's say, people 16 to 24, than it is for people 45 and up. Okay? And so this is, and you can see here, like I said, I think it was last week, if we'd been taking this class exactly 10 years ago, the unemployment rate then was about 10%. So it was massively higher than it is now. And it has come down steadily for this long period. And as you can see, at some point, when the economy has been improving with a lower unemployment rate, it eventually stops improving, and we go into a recession, unemployment rate falling, recession. And so there's some question about where this is headed. Are we right on the cusp of a recession in the near future? Or is this unemployment rate going to continue to stay low for a while? And you can look, this is an article from about a year ago in the Wall Street Journal that broke out the data on the unemployment rate by age group. So the highest series here is for people with less than a high school degree, whereas the lowest series here is for college, and the axis here is the unemployment rate by educational attainment. And you can see that all groups, starting right about here when we entered a recession, all of these groups all 4 educational groups saw a big increase in unemployment, but the increase was much greater for high school dropouts. So their unemployment rate went from like 7-ish% up to almost 16%, whereas for people with a college degree, it never got above 5%. Okay? So educational attainment is a key predictor of what the unemployment rate is going, of how likely a person is to be unemployed. And there are really 2 things that have driven this decline recently in our unemployment rate. One has been employment growth. So if you look over time, so this is the percent change in the total number of jobs over the prior 12 months. So it's basic, and you can see that when we entered this recession, so things were going had been getting better and better, and then job growth slowed somewhat here in 2006 and 2007, and then it fell off a cliff with like a 5% drop in the number of jobs. Okay, but what you see is that we had very strong whether this is strong job creation or not often depends upon what time period you're looking at and whether it's Obama's team presenting it or Trump's team presenting it. But you can see that the growth in the number of jobs has been pretty steady at about 1.5% relative to the previous year. So that's part of the reason that the unemployment rate has fallen. But it's also the case that the fraction of people in the labor force has fallen a lot. So if you look from in the mid-2000s, the labor force participation rate in the US was about 66%. This is for people 16 plus. So both of these series represent 16 plus. And if you look, during the recession, that started to fall. Okay, it fell a little bit, down to like 65.5% during the recession. But then it continued to fall. after that, and it fell all the way down to 63%, which is about where it is now. Okay, this 3% reduction in the labor force participation rate is about 8 million people. Okay, and that has not recovered. So I mentioned before that you're sort of in one of three categories. You're employed, you're unemployed, or you're not in the labor force. The number of unemployed can fall for two reasons. You can go into the employed category, or you can go into the not in the labor force category. And a big reason that unemployment in the US has come down so much is that we've seen a huge reduction in the fraction of adults who are in the labor force. And so a good example, let me show this. This is a study from almost 5 years ago from the Wall Street Journal about the case of the vanishing worker. And this article, so let's pause. I'm going to pause here for a second to look at this, but this basically was looking at places in the industrial Midwest, looking at how their economies had performed. And it was making the point that, yes, unemployment rate has fallen in these places. The unemployment rate mirage in the Rust Belt. Jobless rates are plunging in metro areas like Decatur, Illinois, yet these cities have struggled to recover. So if you look at the unemployment rate in a number of cities, for example, Flint, Michigan, you see that it went up to like 15% at the peak of the, when the economy was at its worst, was all the way down to 6%. But then in this same article, they show that in Flint, Michigan, the number of people in the labor force was down about 12% over that period. And so a big part of what drove the reduction in the unemployment rate in Flint, Michigan was not so much that there were new jobs that were being created in Flint, Michigan, but instead that a lot of people who had lost their job just dropped out of the labor force permanently, okay? And so that's like and you can see that the fraction who are employed has gone up somewhat. So basically, it was at about 58.5 here, and it's up around, near 61. So two factors have contributed approximately equally to this huge reduction in the unemployment rate. So here we have this big reduction from 10% down to 3.6% now. Okay, and about half of that has been caused by an increase in being out of the labor force, and the other half has been caused by an increase in employment. So I'm going to pause there for a sec, see if you guys have any questions. We got the question way back. What do you think? Should I try or not? Can you tell Emma in front of you that I'm about to? Great catch.
Okay, so right after that 2008 recession, a bunch of people just completely dropped out of the labor force. And I know you said that, maybe being discouraged after not finding a job or just being at retiring age might cause you to drop out of the labor force, but what caused it to happen at such an increased rate? I guess that dropping out of the labor force.
Yeah, why did it go up? Why did people drop out of the labor force?
Yeah, and was that catalyzed by the recession?
Yeah, I think I'm pretty confident that it was catalyzed by the recession. I mean, one factor that is going to tend to lower the labor force participation rate over time is changing demographics in the US. So if you look, a person who is 65 years old is less likely to be in the labor force than a person who's 45. And so the population in the US has been aging. And so part of that labor force participation decline would have happened even in the absence of the recession. But it came about, as you can see, as the economy fell into recession. Most of it happened after, and it's flattened out since. I think, the story that people tend to tell on this is that, let's suppose I had a good job, I was making, $18 an hour, $24 an hour, whatever. I'd lose that job, and then I now start trying to find a job, can't find one. My skills are deteriorating over time, and maybe I apply for a government program to help, whether it's food stamps or disability benefits. It's possible that causes some people to leave the labor force. I've done some research showing that when the economy does poorly, more people apply to get onto programs like disability insurance. And that would cause them then potentially to say, you know what, I'm not going to bother to go back to work. I can't make what I used to make. and so I'm just going to stay out of the workforce. So I think the longer someone is out of work, the more their skills will have atrophied. And I think then, the payoff, and we talked a little bit about the hourly rate being a factor that influences whether people decide to work at all. It may be that it deteriorates so much that they stay out. But it's a huge change in a relatively short period, and it's not the case that it's also happening in other countries. As I'm going to show you in a few slides, in the US it's happened more than it has in Europe and other parts of the world. Do you mind passing that? Someone else have a question? Great.
You mentioned earlier the 60,000 people for the population survey. Is that what is used to determine the entire sort of unemployment rate?
Yeah, so is that used to determine the entire, yes.
Okay.
So they basically try to get a representative sample of the population, and so it's measured with error, and it is the case that, so sometimes if the unemployment rate goes from 3.5 to 3.7, some of that could be just statistical sampling error.
Right.
You know what I mean? Because there's some true number of people who are unemployed at any point in time, given the definition of unemployed, and you're trying to get an estimate of that with this survey.
Okay.
Yeah, great question. Okay, other questions? Yeah, we got one back here. No problem. Okay, thanks. Yeah, can I?
Okay. So that percentage unemployed, I mean, they have to be persistently going to the unemployment office and filling out those forms and all that?
No, you could just be looking for a job. You may not even, so there's something called the take-up rate. So many people who lose their job are eligible for unemployment insurance, like you talk about, and they go to a local office to fill out the forms, but you don't have to be collecting unemployment insurance benefits to be counted as unemployed.
Oh, okay.
Yeah, and I'll show in a second that a bunch of people who are unemployed are people who are re-entering the workforce. So suppose that you left the workforce to go, let's say, get a master's degree, and now you come back into the workforce. You may be counted as unemployed for a little while as you're looking for a job, potentially. Okay, so the employment to population ratio has not fully recovered. It had been increasing. Fell a lot during this recession. It's been growing somewhat, but it's still below where it was at its peak. This data isn't totally up to the minute. It's about a year old, but it would be about here if we had the more recent data. And so this study, though, this was a really interesting article that made the point that falling unemployment can be good news, but it can also be in some respects, bad news. If the unemployment rate is falling because everybody who can't find a job just gives up, that's not a great thing. Whereas instead, if the unemployment rate's falling because new jobs are being created and people are finding work, then that is a good thing. Okay. And so if you look over a longer time period, labor force participation has been changing quite a lot over time. So the labor force participation rate among men in the US has been falling a lot for decades. So if you look back in the late 1940s and early 1950s, the labor force participation rate of men 25 to 54 years old was about 97%. So out of every 100 men 25 to 54 years old, only 3 of them were not in the labor force. And then there's been this steady decline in this and it fluctuates as a function of the economy, but you can see that it's fallen quite a lot, so that today the not in the labor force, that percentage not in the labor force has gone from about 3% to about 12% or 13%, 11%, I'm sorry. About 11%. So that's a big change over this period. And what factors do you guys think explain that? You want to throw it? Here, wait, I'll come up. Great, thanks. Here you go.
I mean, more people are also like going to college and getting like doctorates and going beyond
Yep.
even just a 4-year degree. So if someone's a student, usually they're out of the labor force. I mean, there's exceptions, but like a lot of the times in like the GSS and the census and stuff, student is its own category that
Yep.
doesn't get factored in. And that has been like steadily increasing too.
Yeah, that's great. Okay, other factors that you guys think influence it?
I think one might be a little bit of changing gender norms so that it's okay, even if you're a man, to like not have a job or see.
Yeah.
And then I think the other one is that probably a lot of the more physical labor jobs that have been made obsolete were probably more predominantly taken up by men, and so those have been going away.
Right, like manufacturing and construction,
Right.
for example. Right. Yeah. Yeah, those seem like good. Any other reasons that people can think of? Okay, so yeah, those are definitely, I think, key ones. Some people have argued that it has become more. It's become easier to be out of the labor force because of the generosity of the safety net has grown. In other words, it's possible to be out of work and be collecting benefits from, let's say, food stamps or disability insurance. That's another possible contributor to this. But it's a pretty steady trend. Now, if you look for women, the trend has been in the exact opposite direction. So this is very supportive of this changing gender norm story. If you see back in 1948, the labor force participation rate among women 25 to 54 was about 34%. So among men, it was 3 times higher then. Okay? And then it's basically steadily risen for 50 years until about here, and then it's flattened out since. Okay? And so that is a huge change in our economy that happened during the 50s, 60s, 70s, and 80s, and 90s to some extent, but it has remained pretty flat since. The US is actually this decline in labor force participation for men and the flattening for women, we kind of stand out relative to other industrialized countries with respect to our labor force participation rate. We've been falling behind other countries by this metric. And so as you can see, this is a figure taken from a guest lecture by Karen Dinan. So she used to be the Assistant Secretary of the Treasury for Economic Policy. And she came and guest lectured in November 2016. She's now on the faculty at Harvard, but she presented this really interesting data looking at male labor force participation in the US and in other countries. And the bars represent the level in where is this? This is in 2014. And these diamonds above them represent where it stood in 1990. Okay? So if you look at this, you see that, let's grab one other thing. If you look at this, you can see that the labor force participation rate for men in the US over this 24-year period from 1990 to 2000, you see this gap right here represents a pretty big decline. So in 1990, by this metric, labor force participation in the US was comparable to what it was in other countries, whereas by the end of this, by the more recent period, we were falling behind those other countries. And so that is something that people have been somewhat concerned about, that this decline in the labor force participation rate now maybe it's good. Maybe that's a good measure. Maybe people are out of the labor force because they have enough money, but we're now behind other countries like Switzerland, like Germany, like Canada, in terms of the fraction of men who are working 25 to 54. And similarly, wait, why is this not coming up? Oh, okay. Similarly, for women, if you look, also 25 to 54. So 25 to 54, that age group is called the prime age So when people talk about the labor force participation rate, they'll often try to zoom in on this group. And what you see is that back in 1990, so for prime age females, participation has fallen behind that of many other countries. So if you look in 1991, the fraction of women in the labor force was about 75%, and by 2015, it was still at about, it was, if anything, a little bit lower. And we were middle of the pack on this metric in 1991, but then we're in behind other countries. And so this is something that people are trying to understand. Why is it the case that in the U.S., and some have argued that one reason for this is that if the policies for paid leave make it easier for people in Europe and Canada and elsewhere to be out of work for a little while and return to work than in the U.S. So some have argued that the generosity of, let's say, public support for daycare among people who have had a kid is higher in those other places, and that partially explains why we are lower on this metric. I'm going to pause for a sec to see if there are any questions or comments on this. Okay, cool. One thing that is true is that unemployment tends to rise in recessions. And Irina Asmundsen, this is taken from the NBER, and as she rightly pointed out, it's this NBER group that decides when recessions have happened. And if you look over the past 50 years, there have been 7 recessions in the US. Okay, the most recent one was in December 2007. As you can see from this figure, if you look over the last 50 years, we are right now in the longest period without a recession that we've had in over 50 years. So this recession, the December 2007 recession, started right about here. The March 2001 recession started right about here. The July 1990 recession started right about here. You can see in all of these cases, the unemployment rate starts to rise rapidly. July 1981 recession was right about here. The January 1980 recession, right about here. So things actually looked like they were starting to recover from July 1980 to July 1981, but then we went further into recession. This November 1973 recession here. So in all of these cases, you can see that when economic output starts falling, the unemployment rate starts rising. And it is right now a big question as to whether the unemployment rate will, and whether we'll enter a recession. How many of you are freshmen? Okay, so most of the people in this room are freshmen. How many of you think that we'll either enter a recession, that we'll be in a recession when you graduate, or be in a before you graduate, or at the time you graduate? What's your prediction? What do you think from this figure? Nobody thinks we're going to be in recession. That is okay. Okay. So I actually finished undergrad when right about here. So when at that time, like almost 8% unemployment didn't seem like horrible. It paled in comparison to what we had later. But it will be interesting to see. It's somewhat. It would be kind of unprecedented if this were to continue to do this. You know what I mean, for the next few years. So it seems plausible, given past performance when the economy has been improving for a long time, that things will increase a lot. But this matters a lot for all of you, obviously, when coming out of here. Okay, and here is my final slide. I think we're going to finish a couple minutes early, which will be a first for me. So reasons for unemployment and the number of weeks unemployed. So if you look at those 6 million people who are estimated to be unemployed, there's 6 different reasons that, 6 primary reasons for being unemployed. The biggest category actually is re-entrants. So these are individuals who have been out of the economy, maybe they or are entering the economy for the, this is re-entrants. So people, I think a very large part of this group would be people who left work for a period of time, let's say to spend more time with their kids, and they're re-entering the labor force. So that's almost a third of individuals. Next most common is permanent job losers. What does it mean by permanent? It means that you're being sort of terminated, and it's not like your company is going to ask you to come back in a month or 3 months or what have you. Whereas a pretty big group is on temporary layoff. So quite often a person will be working and they, the company will say to them, look, we don't have enough demand right now for us to employ you, but just hold off, just give us some time and we'll bring you back when demand recovers somewhat. This is individuals who are on temporary layoff. Job leavers, so this would be individuals who are in a job, and they decide this isn't the job that they want to go find something new, and it's actually hard if you have a job to search for a new job, so they may decide, I'm going to leave my job and start looking for a new job. About 1 in 9 people who are unemployed were working in temporary jobs, so there are these agencies called temporary help agencies that basically get people into companies, but for just short-term arrangements. And then finally are the new entrants. So each of you may be in this category in a few years if you decide to go to work initially versus go to grad school. What fraction of you think that when you graduate you're going to work rather than go to grad school? Okay, and what fraction do you think you're going to go to grad school immediately? So it's about a 50-50 split. And then, and then you can see also in terms of the duration of unemployment, you can see that most people have been unemployed for less than 3 months. And this is the group that we tend to refer to as the long-term unemployed, who have been out of work for more than half a year. And there's huge geographic variation in the unemployment rate. So if you look during the 2007 to 9 recession, Michigan was actually the state that was hardest hit by the recession. I mean, there are some other countries like Arizona might argue they were even harder hit, but I think Michigan was just about the hardest hit. Michigan is differentially in auto manufacturing and the industries that support auto manufacturing, and the number of cars purchased in the year in the U.S. went from 17 million to 10 million, and that had a huge effect on the number of people with work. Whereas in North Dakota, nearby North Dakota, the unemployment rate then was only at 4%, and partly that was because North Dakota has had a lot of people working in the energy industry, specifically in like fracking there. But if you look now, 10 years later, Michigan has come down a lot, and North Dakota, things have improved somewhat less. So I had a couple more slides today, but I thought 38 slides was enough, so we got through things quicker than I expected. Yeah, have a great rest of your day, and see you. Don't forget section today or next week, and we'll see you in class today or tomorrow for section. Okay, see you next